How weird is that? My skin makes the light come on. Wonder what my tongue will do. My tongue is conducting the electricity. Don't try this at home, especially with 120 volts. Okay, so what have we got here with the 820 ohm resistor? We have 11.6. Can you catch that? Okay, so let's go smaller. 820, let's go down to half that. Here's 470 ohms. Now that's really bright, 19.6. So I would say that is probably your upper limit. We're just shy of 20 milliamps with that light, but we've got the resistor. So we sized the resistor to accommodate the battery. So let's take it one step farther. LED again, we blow it, we don't care because we got lots of them. So going through the ammeter, there we go. We got a light. I'm seeing 2 milliamps, 24 volts, 2 milliamps. So let's go down to, let's go to the 800, see what happens. Quite bright. What are we reading? 26. So we're high. I want to be under 20. So we got an 820 ohm resistor. Let's go up from there. Let's go 2700, because that's the next one I got. So light's working. 8 milliamps. So we can get between those. What's between 820? Okay, here's 1800. That looks pretty good. Nice and bright. 12.39. I'm going to talk about the Bowmanville Lampagoid, probably the oldest one that I've built a long time ago. And I built this when I had a house full of kids. And I built it so that I could test things. I can go 0 to 120 volts AC. I can go 0 to 35 volts DC. So you can test practically anything. And because it's variable from 0 up to voltage, you can creep up on a device rather than just plugging it in and hoping for the best. I can bring it up slowly so I don't burn it out. So I'm going to demonstrate how some of these things work. Now on this side I have a variable transformer. Right now the voltage is at 0, though it is turned on. Now the significance here is these two lights are same as these. These are neon flicker lights. Now neon lights of any kind don't work until they get up to about 80 volts. So I'm going to bring this up slowly and you're going to see one of them turn on. There's the top one starting to go, the bottom one hasn't, and we're at 82 volts. I'll bring it up some more. There's the other one, almost 100 volts, and I'll take it all the way to 120, which these on the right side are running 120, but this is on the variable, so if I turn it down they'll dim and then they'll stop working. Okay, so that's the AC side. Same with this outlet here, it's also on that variable transformer, so you can run a fan up and down or a motor, whatever you want. Now over here, this is the DC side. I'm going to switch that on, and it's controlled by this. These are the DC meters. The top one is the voltage, the bottom one is the amperage. You notice there's nothing showing on the top, so I'm going to bring that up. And it's hooked up to this lamp down here. This is a 12 volt halogen like you'd have in a home shining on a picture. Now we're right now at about 5 volts. So you might want to go a little wider on this. It's going to get quite bright. You notice the amperage is half scale right now. It's gobbling up current. So that's 12 volts. That's its rated voltage. And we're running at about 6 amps right now. If I take it higher, it'll burn out. Anyway, that's pretty much it. I'm only up at just maybe 14 volts right now, but I can go much higher. But again, it's infinitely variable. And that's kind of it. Really useful for testing stuff around the house and so much more. Now I can plug in a secondary transformer and take the 120 up to 600, so I can go 0 to 600, which is really dangerous. You want to know what you're doing and not be standing in a puddle with bare feet when you're playing with that kind of voltage. Anyway, I keep it on my bench here. I use it every day for something. I'm the go-to fix-it guy around here. When something doesn't work, it usually lands on my bench. And that's about it. Any questions? How much did it cost? Well, not a lot, because I built it with found goods. But to build it from scratch right now and buy new components, probably $1,500 plus your labor. But I've had it for 20 years. And still working.
How many different designs have you made of this? Variations?
Well, we use variable transformers in movie making all the time. That's one right there, the red toolbox. And I'm just using it right now to run a light on my machine. This is a light that I swing it around to my machine so I can see what I'm doing, and I can crank it up really bright. That's not quite full voltage, but the beauty of LED lights is when you dim them, they don't change color, whereas incandescent bulbs do. It just gets dimmer. So, but they have all kinds of uses there. You can charge a battery using a variable transformer. You can control the speed of a motor. You can run a heating element and throttle it to where you like it. I'm gonna put out a thing on my website, 10 things you can do with a variable transformer. And they're expensive, but by God, they're useful. Anyway, that's what's at the heart of that unit, and there's probably a dozen of them in the shop somewhere. They often use them on set for dimming light. Anyway, I'm good with that.
Codebreaker. Good. Can't wait to meet him. Right this way. Jones.
Well, imagine a skeleton inside a person. We're going to duplicate a body. So we're going to build a skeleton inside, but it's not like the one that God made. It consists of joints in the right places, certain adjustability, generally made out of metal, steel, or aluminum, possibly fiberglass, so that the shoulders, the elbows, the wrists all move properly when positioned. They may or may not have motors or air cylinders or something driving them. What to me makes an animatronic is something that's got electronic. There's some degree of electrical instruction being carried out in the creature, whereas a move that's done with cables, like a hand that would have function, or eyes blinking and whatnot, that's cable. It's not animatronic. And that skeleton we call an armature. Nothing to do with an arm, it's just what's inside that provides the motion.
Go ahead, chalk the flat line, then let's quit.
Okay, everybody clear.
Officer Alex Murphy shot to death in the line of duty.
Legally, he's dead. We can pretty much do what we want.
There's a new guy in town. His name's RoboCop.
Okay, here we are. We're going to do an experiment with this relay. This is an 80 amps, huge, but it gets turned on with just the tiniest amount of voltage. And what we're going to do is we're going to look at on the meter here, we're going to see when the when the relay pulls in. Turning on the light, and then I'm going to dial the voltage back, and we're going to see it drop until it drops out. And we're going to record those two numbers. So I'm going to just get a sheet of paper here. All right, so here we've got plain old lamp cord, 18 gauge, 2 wire, you would buy for your living room lamp. We call it zipcord in special effects. I'm just going to bare the ends here so I can use it. Polarity does not matter, as in positive and negative are not relevant on this relay. So I'm going to use the big lampagoid here to hook up a couple of wires here. Alright, so I'm going to bare these wires here, add a couple of alligator clips. Alright, so I'm hooking these wires up to the coil, which is the electromagnet on this relay. Alright, here we are. Get rid of that. So we're powered here, but there's nothing here. What are we showing here? 0? Alright, so I'm going to start bringing that up. Over here. There's about... Want to read it off? Okay, what's it reading now? 801. Let's do it again. Okay, so now we're going to go the other way. We're going to go down and see where it turns off. Okay, so 237, 2.37, and it was 801. All right, so 801 is pull in, 237 is drop out. Now the difference between this is known as the hysteresis. So instead of it dropping back out at 800, it goes all the way down to 237. And this is valuable when you want to hook up a windmill and you want the windmill to have gained some speed before it's engaged with charging the batteries. So you're isolating the charging device, the generator, from the battery pack so that the generator, when it's idle, is not drawing any power. So the relay disconnects the two of them. So as the windmill speeds up and the voltage goes up, it'll kick in, and then we're charging batteries. And when the wind dies down, it drops out and they're isolated. That's it. That's the purpose of this relay in that type of a setup.